1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Tikiuosi viskas yra gerai. Taip. Taigi, dabar mes eisime prie aiškinimosi šio trikampuko. Tai yra trikampukas, kuris yra sugeneruotas štai šio kodo. Šis visas kodas sugeneravo šį trikampį. Šis kodas yra C++ kalba ir naudojama OpenGL technologija. Tai išsiaiškinom visų pirma, kad čia yra Vertex shaderio programa, Vertex shader program, į kurią OpenGL kreipiasi, kai jisai nori sužinoti, kurioje vietoj viršūnę, piešti. Tai čia nurodoma versija, kuri yra inicijuojama, OpenGL. Čia yra parodoma layout location 0 yra vieta, kuri randasi OpenGL Vertex input state. Tai mes naudojam input 0 šiuo atveju. Ir mes per šią vietą, mes paduodami šį input 0, mes kreipsimės į štai šią programą, į štai šį kintamai, kuris yra čia, kuris yra vec3 tipo ir jo pavadinimas yra apos. Toliau yra void main programa. Vec3 tipas yra iš esmės trijų dydžių, trijų elementų arėjus, Void main, paskui eina void main programa ir, eina OpenGL position, tai yra kintamasis, kurį nusako pats OpenGL'as, ir jis paima vec4 tipo kintamai, vec4 tipo reikšmę, į kurią paduodam vieną iš jų, 3 iš jų paduodam apos, tai čia jau 3 reikšmės šitas va ir yra tas apos, o ketvirtoji yra vienetas. Ketvirtoji reikšmė yra W, kuri dirba su perspektyva, tai yra kameros perspektyva, Tai, šitą reikšmę man čia GPT pasiūlė, sako, dabar tu šituo dalyku nesirūpink, dabar tu šitą dalyką palik ramybėj. Dabar man klausimas, kur yra, ir čia dar keletą dalykų išsiaiškinam, paskui prieisiu, bet pirmiausia, aš supratau dar vieną klausimą, kurį aš turiu. Tai visų pirma, kodėl, tai va, dabar turim tokią situaciją. Čia yra pointeris, char pointer vertex shader source lygų šitas stringas. Čia yra pointeris į šito, čia yra iš esmės, char charų arėjus, nes šitą sintaksą galima naudoti, kaip ir stringui, std stringui, taip ir charų arėjui. Tai šita sintaksė šiuo atveju nusako charų arėjų, tas charų arėjus pointeris kreipiasi į pirmą šito charų arėjų simbolį, tai yra tą hashtagą. Ir mes šitą adresą talpinam šitame Vertex shader source, bet aš dabar ko nesuprantu, tai kur tada dingsta visą šitą string, jisai dabar ore, ta prasme, kabo kažkur ar dar kažką, aš nesuprantu, kur dingsta tada visas šitas stringas. Tai vat šitą aš noriu dabar išsiaiškinti ir noriu pasiklausti GPT. Čia dabar yra, šitą reikia ištrinti. Gerai. Taigi, tai aš noriu pasiklausti, kodėl, ką reiškia, kad mes šitam kintamajam turim tiesiog pirmo simbolio adresą, o kur dingsta va šitas va visas char array'us. Tai dabar klausiu aš jo. Copy. Hi. I have this. O, čia vanduo mano reikia atsigerti. Taip, tai būtų hi, I have this expression in an OpenGL triangle program. This is a shader program. What I don't understand. What I don't understand. Why is okay? What I do understand is okay. The question I have now does not take into consideration the shader program code, rather than how we manage it. We have a char pointer which as I understand points to the first symbol of this string, meaning this one. So we have the char string. Okay, so we have the address of the first symbol in the variable. Now, what I don't understand, we don't store the string, the actual sequence of chars anywhere. Now, what I don't understand, we don't store the actual sequence of chars anywhere. We only store the address of the first char. And so how does the program recognize the char sequence, the shader program and can work with it if it's not stored anywhere and it's just mentioned once in program. Great question. The key idea is that the string is stored somewhere even though your variable only contains a pointer. Nu, aš jo šitą įtariau kažkaip, kad tai gali būt. However, jo, gerai. Tai step 1. What the compiler does? The compiler sees all adjacent string literals and automatically concatenates them into... gerai. This complete string is stored in the program's read-only data section, often called arrow data, when the executable is built. Conceptually, memory might look like, okay, ir null terminator. What the pointer stores, the variable, okay, contains only this, which is the address of the first character, yeah. How can it find the whole string? Because C-style strings are null terminated. What? What does it mean? Because C-style strings are null terminated, the compiler automatically adds a 0/0 character at the end. Okay. So, blah. Gerai, tai žodžiu, tai čia jisai compileris prideda šitą null dalyką. Functions that work with C strings start at the pointer and keep reading characters until they encounter a /0. For example, printf, okay, nežinau ką tai reiškia, internally does something like char p lygu vertex shader source. While pointer p is pointeris į p yra nelygus šitam, pointeris į p, tai yra p pointeris, atsiprašau, ir p plus, tai čia p pointeris, tai output p. Output p, tai output, palauk. I don't understand this. Čia output, tai čia yra pointeris į p, tai turiu omeny, čia yra pati reikšmė, į ką p pointina. Ir while šitas dalykas nelygus, tai output p pointeris, tai kaip suprantu, jisai sako, kad žodžiu, kad tu parodyk man, kas yra tame pointeryje. Žodžiu, nu čia, nežinau, ar output čia tiesiog yra gal tipo pseudokodas, o gal ir ne. Žodžiu, ir p++, tai plus p. Tai žodžiu, tai plus p, tai kaip suprantu, jis eina į sekančią atmintį. Ir tai jo, tai šitas tada pointina į reikšmę, kuris storinama yra p adrese. Čia tai p yra adresas, pointeris į p yra reikšmė, kuri yra tame adrese, ir p++, tai mes padidinam adresą vienetu. Ir mes einam į sekantį charo arėjaus, žodžiu, tą elementą. So the pointer doesn't need to store the entire string. It only needs to store where the string begins. Where is the string stored if it appears only once? The string literal itself is an object created by the compiler. For example, blah 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 hello is roughly equivalent to... Nu, taip, jo, šitą suprantu, jo, ok. Const char, ok. The compiler generates that hidden array for you. Hidden array, char s, the compiler generates that hidden array for you. Ai, nu, tai turiu omeny, the string literal itself is an object created by the compiler. For example, blah blah is roughly equivalent to blah blah, and žodžiu tai gerai, jo. The compiler generates the hidden array for you. Ok. Ai, supratau, tai jisai šitą sugeneruoja, žodžiu. Static const. Blet, man reikia prisimint, kas static reiškia. Fuck me. Gerai. Visual picture. Taip. Memory vertex shader source. Taip. The pointer variable contains only the address, but the actual character sequence exists somewhere elsewhere in memory as a compiler-generated array. Okay. It's čia difficult, čia yra intricate and difficult F, but very interesting. Labai įdomu, čia negražus. Jo, man reikia nevalgyti per streamą. Gerai, biškis valgys. Tai iš esmės čia turime sugeneruoti arėjų ir tas sugeneruotas arėjus, žodžiu, yra paduodamas į šitą formulę ir jisai žino, kaip su juo elgtis. Čia jis automatiškai žino, kaip su juo elgtis. Man įdomu, o kodėl yra šitas palengvinimas? Reikės dabar mėsytę suvalgysiu ir man įdomu, kodėl yra šitas palengvinimas. I think I got it. But this is a specific way C++ works. Why did this workaround to strings appeared? Is it for memory efficiency optimization reasons. Meaning person usually didn't initialize the same string over and over and just called the memory of the first L of the char array. They went from there. This behavior comes largely from C's history, and C++ inherited it. Why did C use pointers to strings? Back in the 70s, when C was created, computers had extremely limited memory. It was important to keep the language simple and close to the hardware. Something like a string, literal like hello, was naturally represented as an array of characters in memory. Yeah, the designers could have invented a special string type that stores both a pointer to the characters, the length, but that would have required additional language features, runtime support, and memory. Instead, they said a string is just an array of characters ending with a null symbol kažkoks. This made strings very simple and efficient. Why use a pointer? Suppose you have char string array hello, char str array hello. This creates a copy of the array. But if you write hello, you only store an address. The string literal itself lives elsewhere. The pointer. Oh, palauk. What? This creates a copy of the array. Tai tu turi omeny, kad šitas ir kintamasis, kuriam šitą reikšmę priskiriam, tampa du stringai vienu. Jie tampa du stringai tipo. Du atskiri stringai. But if you write this, you only store an address. The string literal itself lives elsewhere. The pointer is typically 8 bytes of a modern 64-bit machine, regardless of whether the string contains 5 characters or 5,000. Reusing literals. Another advantage is that identical string literals can be shared. For example, reusing literals. Another advantage is that identical string literals can be shared. For example, a compiler may store only one copy. This is called string pooling or string interning, though the exact term depends on the context. This is super interesting. Tai čia labai įdomu. Tai man iš karto natūraliai kyla klausimas. Tai char arrayus neturi length. Ta prasme, jeigu mes norim sužinoti char arrayus lengthą, mes turim iškviesti kažkokią funkciją, ne? Why does this seem weird today? Because modern languages usually hide all this. For example, Python, the object internally stores metadata such as length, encoding, reference count, character data. You don't see any of that. C, however, exposes the underlying memory model almost directly. Okay, which really means, šitas really means here's the address of the first character. Good luck! That design made C fast, simple, and portable for the hardware of its time, and C++ kept compatibility with it. That's why OpenGL APIs, which were designed around C, still commonly use const char for shader source code today. Nu, man čia super įdomu šitas dalykas. So, okay, so when I write a string literal somewhere in the program, even if it's the only thing on a line, even if it doesn't even if it isn't assigned to anything or whatever, just a plain string sitting somewhere in the code. If it doesn't produce an error, I don't know. I haven't tried. If it doesn't produce an error, then somewhere in the code. Doing nothing. The compiler creates it in the, kaip tas failas vadinas? It creates it in the kaip tas raw data, read-only data, raw data file, and I can get the address of whatever strings first character I please and wait, please and just with it. How about the length? If I to count the length of a char array, I have a built-in function, or do I have to calculate it manually with a loop? Excellent questions. Let's separate a few concepts that often get mixed together. What if I just write a string literal by itself? This is valid C++. No, yeah. The statement does nothing. The value of the expression is discarded. The compiler is allowed to create the string literal in memory, but since it's never used, an optimizing compiler will often remove it completely. So this does not guarantee that hello ends up in the final executable. Yra optimizing compiler. Optimizing compiler, you mean this that is standard in any, for instance, G++ compiler suite. Or a specific type of compiler of C++ compiler that you have to know, that you have to get somewhere. Can I get the address of any string literal? Yes, type here P is, yeah. So reference to hello 0th index. Are all string literals stored in ORO data? Conceptually, yes. Although the exact section name depends on the compiler, platform, and linker. Typically, you'll find string literals in a read-only segment because modifying them is undefined behavior. Typically, you'll find string literals in a read-only segment because modifying them is undefined behavior. Type. Okay. Ir P char array. Hello. Tai čia yra šito nesuprantu. Platai čia yra tipo čia yra typas, žodžiu, tai kaip suprantu, tai pasitikslinsiu. This means that the char pointer hello part means that the hello is treated as a char pointer, meaning just the address of h and then we pass this address to the p variable. So then we set this address as p. Why do we need a typecast here, as if I remember correctly, we can just do string char array address Lego string, and we're just getting the address of first character. No? How do I get the length? There are two very different cases. Case A, actual array. Memory, yeah, the compiler knows the size at compile time, size of R. Returns 6. 1, 2, 3, 4, 5 ir 6 tas. Because the null terminator counts. To get the character count is -1. Returns 5. Size of P returns the size of the pointer itself. Okay, party. This sets the array and this creates the copy, okay? Not the strings. The compiler has lost the array size information. Okay. Do I have to count manually? No, the standard library provides str length. Oh, internally it's essentially okay, I got it. Yes, so yes, the library function is doing the loop for you. Why doesn't the pointer know the length? This is one of the most important things to understand about C++. A pointer contains only an address. It does not contain length, capacity, ownership, information, type of allocation. Nothing else. When you pass a pointer around, the function receives only string, the address, and has no idea whether the memory contains hi or blah blah, or even a string at all. That's why C strings require a null terminator to provide a way to find somewhere where the string ends. This distinction between is one of the most important C++ things. Many beginners are surprised that these look similar but behave very differently with size of. So, okay. So taip. Okay, so I'm very deep into actually, because I have no, aš dabar angliškai kalbu, aš neturiu, nelabai yra viewerių, tai aš dabar tiesiog nagrinėjusi dalykus, kurie man yra įdomus. Ir nežinau, ne tai, kad tempiu laiką, bet tiesiog mėgaujuosi procesu. Tai, ko aš čia norėjau paklausti, palauk. So the char R element somehow stores the length of the string. These are exactly the kinds of questions that lead to understanding what's actually happening in the memory. What is an optimizing compiler? Most modern C++ compilers support optimization. For example, GCC, G++, CLang, CLang++, MCVC, Visual Studio. All have optimization modes. With GCC, main CPP typically means a little or no optimization. O02 or O03 enables increasingly aggressive optimization. For example, the compiler might generate storage hello when optimizing. When not optimizing. With optimization enabled, it may notice the string is never used and remove it completely. What does char hello mean? Let's start with hello. What hello actually is. The string literal hello has type const char 6, tai čia arrayus, because it contains šitas. When used in most expression, it decays to type, which points at h, so it's perfectly normal. Why the cast? Suppose you write, modern C++ says error or at least a warning, because you're trying to convert const char into, suppose you write modern, because you write, okay, which would allow modification. The compiler wants to stop you from doing, because string literals are not writable. The cast basically tells the compiler, I know better. Pretend this isn't const. It suppresses the warning error. Šito nesupratau. But it is usually a bad idea. Tai kodėl tu taip darai? Old C behavior. In very old C code, people commonly wrote šitaip, and compilers allowed it. The C++ tightened the rules because too many bugs resulted from accidentally modifying string literals. Today you should write this. Does store the length? No, this is extremely important. Consider memory contains there is no hidden length field, not just the characters. Why does size of R knows No, it's 6 because the compiler knows the type. When you write, the compiler deduces, okay, the size is literally part of the type. Ok, tai tipo, tai kiekvieno tipo ir kiekvieno ilgio arėjus yra skirtingas arėjaus tipas. The compiler numbers R is an array of 6 characters, chars. So size of R can be replaced at compile time with 6. No memory is inspected. No length is stored. The compiler simply knows the type. What happens when you pass the array somewhere? Okay. So yeah, size that can be replaced at compile time with 6. No memory is inspected. No length is stored. The compiler simply knows the type. What happens when you pass the array somewhere? Consider, yeah, you might expect 6, but you'll get something like 8 on a 64-bit machine, because function parameters declared as arrays are actually converted to pointers. What happens when you pass the array somewhere? Yeah, the array size information is lost, only the address remains. This is one of the biggest aha moments in C++. The compiler knows its 6 element, but as soon as it decays to a pointer, all that remains is, yeah, the size information. Čia daug reikalų. Labai įdomu. Aš mėgaujuosi šitu labai kol kas. Ok. Taigi, supratau, kad OpenGL šiaip yra naudojamas nuo C laikų, tai žodžiu ir C žodžiu naudodavo arėjų kaip tiesiog arėjaus pointeriai. Šitas stringas atsiranda read-only faile, kuris atsiranda, kai kompiliuoji, palauk, pažiūrėsiu. Read-only file. Kur šis? Ne čia. .ro. Are all strings literal stored conceptually? Yes. Gerai, žodžiu, supratau. One last question. Where does raw data file appear, and does it disappear after compiling the program? One small correction first. Arrow data is usually not a separate file. It's typically a section inside the executable file that the compiler linker produces. During compilation and linking, suppose you have this. The compiler generates object code and data. The string literal hello is usually placed into a read-only data section called arrow data. Conceptually, the executable might contain sections like text, arrow data, data, and BSS. Zero initialized. Oh my god. Okay. I got it. It's in the executable. It's clear. Thanks. Okay, so I got this part. It's now clear to me. Aš vėl angliškai kalbu. Šitą vietą pilnai supratau. That's nice. Tai šitam streamui kaip ir bus gerai. Pabandysiu kitą kartą šiek tiek daugiau paeiti priekį.